Hello friends, welcome to Shiksharthi. In this session, we will be talking about the limit or limits of a function. So let's start. Now when we are talking about the limits of the function, the very first thing that we need to understand here is what are the things that we need to know before we talk about a limit on a function or of a function. On a lighter note, you can't limit a function. You can limit some values, or you can limit the range of a function and then limit the domain, or you can limit the domain of the function and then limit the range of the function. So the point that I'm trying to make here is, you in the very first place you need to understand that what are all those things that you need to know before you talk about limits. So one is, you should know what a function is, and you should know what are the investigative parameters of a function, like domain, range, zeros, non-zeros, the inequality aspect, the equality aspect, etc. These are few things that you should have already done before. You would have done this beforehand. Then only we talk about the limits of a function. So the first thing that you need to understand here is the limit of a function is a very generic statement, as said earlier, and we will understand this with the help of the non-graphical way first. So when we are saying limits, in a certain way, limits are nothing but the inequality. So limit is nothing but we are talking about inequality. And when we are talking about limit, we are talking about limit around a point or about a point. About a specific domain value. So when we say point, we are talking about a specific domain value or the input value. So when we are saying this, we are basically talking about limit around or about a specific domain or non-domain value, which is why we are trying to make it look like a very generic one for all, or that in specific input value or values. So this is important. The domain and the non-domain becomes slightly unimportant, because when you're finding out the limit, in that case the point around which or about which you are finding out the limit is nothing but the inequality aspect, because you're not talking about that point, which is why we say that limit is nothing but inequality about a specific domain value or non-domain value, or in short, limit is just like inequality around or about the input values, the specific input values. Once you know this, the point which gets further highlighted here is, if I say around that, so the point that I'm trying to make here is, if I say that limit x tends to a, and if I'm talking about limit of a function fx such that the input value of x is a. So when I say input value of x is a, that means I want to know about the behavior of that function fx around the value x is equal to a. Another way of understanding the same, which does not mean that I am talking about f of a. So then what am I talking about? So when I am saying limit x tends to a fx, the first thing that I am talking about is, I need to understand the behavior of f of a plus. And the second thing that we need to understand here is, we need to understand the behavior of a minus. A minus means the value which is very close to x is equal to a, the value which is very close to x is equal to a but greater than a in the first case, the value, in the second case, the value of x is equal to a, the value, all such values which are very close to x is equal to a but lesser than a. So in this case, we can say this is nothing but limit of, let's say we introduce one more variable h tending to 0, wherein f of a plus h, and this becomes nothing but limit of h tending to 0, f of a minus h, which we call it as right hand limit and the left hand limit. So this is, let's call it as RHL, which is right hand limit, and we call this as LHL, left hand limit. The third point which is given rise to consequent to 1 and 2 is, now when you're talking about the range, we know that the range is the neighborhood value, the neighborhood range for those neighborhood input of the neighborhood input, whether it is domain or non-domain, that does not make any difference here, but we are talking about the neighborhood input values behaving in a kind of output values. Okay, so in that case, when you can measure something, then only you can talk about it. You can't talk about something which is immeasurable. So you will say that the limit x tends to a of a given function fx, irrespective of whether x is equal to a is a domain or a non-domain element. We are just concerned with the input here, should be equal to the left hand limit, should be equal to the right hand limit, so let me put it once again. So the point that I am trying to make here is the limit of a function fx when x tends to a exists only when the left hand limit, which is f of a minus, is equal to the right hand limit, which is equal to f of a plus, is equal to a finite number. Finite number means it should be measurable. I hope you have understood this. Hope. So the limit of a function exists only when the left hand limit is equal to the right hand limit and is a finite number, which means it is measurable. Now let us understand all this with the help of a graph. So the second point, or the first and the second point, if I have to understand this with the help of graphs, let me draw a straight line here. This is, let's say, the point x is equal to a. Now the right hand side, when we are talking about, so let me just extend this line is x is equal to a. So the right hand side, you will say, is nothing but when x minus a is positive. The left hand side of the point x is equal to a is when you would say x minus a is negative. And when you are talking about x is equal to a, in that case we can introduce one more fact here, which we can say that this line is nothing but, the line that we talked about x is equal to a is nothing but when x minus a is equal to a 0. So now when we know that, so this is a diagram that we have drawn, keeping in mind that if I say this is nothing but the negative side of x axis, this is the positive side of x axis, this is nothing but the positive side of fx, and down below is negative side of fx. So the extreme left hand end will be termed as minus infinity. The extreme right end will be termed as plus infinity. Okay, I hope now you would have understood it by now fairly well about that limit is all about the neighborhood values or the neighborhood behavior. It is not about that particular point. So when we are talking about limits, whether it is a function, then we are trying to limit uh, the input values to a function in terms of the neighborhood. I mean the value of that function at that point of x around that value of x, not at that value of x. So we are talking about the neighborhood values is when we talk about the limit of a function. And that is how, so we are limiting the intervals of the domain, giving rise to the intervals or a specific value of a range. That is exactly what we are doing. Let us understand this better with the help of an example. So let us say that if I take a function like fx is equal to x square. Okay, and if I know the graph of this function, it becomes easier for me to interpret. So by now you would have understood it is not only domain, range, zeros, non-zeros, etc. It is the graph as well, which falls under the category of etc. So now if I want to know the limit, let's say the right hand limit of the function fx. So this is just like saying this is nothing but f of 0 plus. So what would be the limit? The limit of the function f of 0 plus will be equal to a 0. So when I made a statement like we are interested, so it is the domain or the input values which have a restriction in terms of either specific values having a restriction, which in any case it is a domain is, the limit is when you are restricting the input values in terms of making it available in terms of a range. So maybe around that, x less than that value, x greater than that value. But those restrictions give rise to a specific range, and that specific range is a finite number. So that when I say is a finite number, that means the range cannot be expressed in terms of an interval. The range will always be expressed in terms of a specific value, which is a constant value. Please understand that. So in short, the limit of a function is when we talk about the limit around the input value, which is if the input value is x is equal to a, then we are talking about the interval x less than a basically, and x greater than a are the intervals that we are talking about, because we are talking about the neighborhood value, the values which are close to a from either of the sides but not equal to a. So the restriction results in the intervals of the inputs giving rise to a specific range, which is a measurable range. Then only the limit can be defined. Okay, now the second example that I want to take here is, let us say that the given function was dx is equal to 1 by x, and somebody asked me to find out the limit x tending to 0 of gx. So before I would have gone ahead in both of these cases also, I would have talked about here the domain of the function is real numbers. In this case, the domain of the function is x less than 0 and x greater than 0, which makes it quite easier to approach the question now, because since x is not equal to 0, so we can only talk about the limit only when it comes to around x is equal to 0. But when we do this, we see that when we are finding out the right hand limit, let us say, in this case, we would say that, okay, limit h tending to 0, g of 0 plus h, which is limit h tending to 0, 1 by h. So, which is plus infinity. Now, before I go ahead in finding out the right hand limit, we have already found out. Before we go ahead finding out the left hand limit, we know that the limit exists only when each of the right hand side and the left hand side have a finite value. So we know that if somebody had given us a question like limit h x tending to 0 gx, where gx is equal to 1 by x, the answer would be it does not exist. So here in this case the limit exists. In the second case the limit does not exist, because when we are trying to find out the right hand limit, that gives me an immeasurable value. But just for the sake of finding out the left hand limit, we will say limit h tending to 0, g of 0 minus h, which is just like saying limit h tending to 0 minus 1 by h, which means this tends to minus infinity. I hope you would have understood this and you'll be able to take this learning to the required level.